We're going to begin with the larynx, which is also known as the voice box. Now, I don't have a good picture. Your larynx is actually this whole region right here. You can see the laryngeal cartilages make up this region. I'm going to change pictures. I'm going to go to this one. And this actually shows, so here's that side view you were seeing before. There's the thyroid cartilage in the back. There's the epiglottis that folds down. So this is a split of the side. And then this is looking straight on from the front. So the larynx itself, take a look. It actually attaches. There's your hyoid bone. I don't know if you can see in Franklin, but oh, you can't see Franklin's hyoid. You can't see Eleanor's either. But they both have hyoid bones up top here. Okay. So anyway, you got that bone that's up underneath your mandible there. Um, and so it attaches to the hyoid bone, and then it runs into the laryngopharynx, which we had on the last video, superiorly, so from there on up. And then you can see as it goes down, we go through the larynx here, and then it becomes continuous with the trachea. Now, there are three functions of the larynx, and obviously we're there to provide a patent airway. So in other words, we've just got this straight shot all the way through. We want to get from the nose or the mouth through the pharynx into the trachea that goes down our chest, but so it's going to provide that pathway. And then obviously it provides a function for voice, and we'll talk about that briefly here in just a minute. But then also you've got this epiglottis here. This epiglottis is going to work as a switching mechanism to route air and food into the proper channels, because we don't need food going down our trachea. When we do that, it causes us to cough a lot. So now, in my years teaching, I've never made my students learn the cartilages of the larynx. So, but you do have all these paired cartilages on here. Now, there are two that are actually sort of important. Okay, the thyroid cartilage, obviously the first one right up front, that's that big shield that we can feel. And that's what makes your Adam's apple. I'm sorry, ladies, you don't have an Adam's apple. Actually, you do, but yours is small. So that's why yours doesn't stick out. With the guys, ours grows so big that it sticks out. So anyway, that's the big one, is the thyroid cartilage. And the thyroid does not actually sit on that cartilage. It actually sits down below that cartilage, which I think it's interesting they call it the thyroid cartilage. So anyway, the other cartilage I think that's important is this one here. It's called the cricoid cartilage right underneath. The reason why this is important is because this is kind of a soft cartilage when you're young, because you're still growing and it is softer. And so if you've ever been around a child and when they cough they've got what's called the croup. The croup is this distinct cough that just sounds menacing. It's a terrible sounding cough. Well, the reason being is that cartilage has not solidified. It's not hard. It's never going to be solid because this is all cartilage, but more solid. Okay. It hasn't firmed up yet. So if you've got a child that's got the croup and you hear that coughing, one of the things you can do is put them into cold air, which is great in the middle of winter. You take them outside where it's cold and let them breathe that air, let that cartilage then cool down. When I was a child, when I got the croup, it was during the summer. Lucky me. So my parents just couldn't take me outside. So my second or third visit to the hospital, who knows? Anyway, it was to put me in what was called a croup tent. And what this tent is you would sleep in this, it was a clear box that went over the top of it, and then it even had a clear flap that came down over your chest. I appreciate it being clear because I could wipe the water off of it, and at least I could watch television out that box. In the back of this, they kept putting ice chips, and it was basically this giant humidifier. So inside this tent, I'm breathing saturated water, but it's also very cold. So they've got me just loaded down with blankets. So I'm toasty and warm, but I'm breathing really cold water. The only complaint I had about the whole thing was the water would come down that plastic. Well, that plastic would drape across your chest, and I would be soaked. And so I'd have to put towels across my chest. And the nurse would come in about every 2 hours and have to pull the soaked towel off of me and put a nice dry, warm one on top of me. But it seemed to do the trick. So anyway, that was all because the cricoid cartilage just hadn't solidified. So anyway, that's why I think that one's kind of important. Okay, so we've got the thyroid cartilage. So we start up top here. The hyoid bone, the thyroid cartilage, the cricoid cartilage, and then the last piece up here is the epiglottis. As far as just this picture, we'll get into the vocal cords here in just a minute. The epiglottis is just this flap. Remember, this is one of the two places where you find elastic cartilage. The other place is in your ears, and so it flips back and forth. But your epiglottis does the same thing. That flap folds down, then pops back up. And so every time you swallow food, it catches on the epiglottis, and it sends the food over the top of your trachea there, so the food doesn't go down your trachea. So it covers your what's called your pharyngeal inlets during swallowing. Okay, let's go to vocal cords. So I'm looking down, base of the tongue always gives you, here's where you're at for your base of your tongue. And there's going to be my epiglottis, which is going to flap down and fold over the top of this because we want to protect this. So when it comes to your vocal cords, basically you've got these elastic fibers that are going to form what are called the mucosal folds, are called true vocal cords. Okay, and you can see the true ones are this one and this one. So they open and close. And then you've got a medial opening between them, and that's actually your glottis. So we have the epiglottis above the glottis, and then we have the glottis, which is the passage through air. So as air goes through these things, we learn to get them to vibrate, and that helps us produce sound. And that's where we learn to make sound. Now, we do have false vocal cords on the outside here, and normally in class, I would tell you, I want you to guess which animal can actually control their false vocal cords, because we can't. And there's only one animal that I know of, but you're limited because, well, it's me. But the only animal that I know that can actually produce sound through their false vocal cords are cats. And as you probably guessed by now, it's when they purr. They're rushing air past those, and they're getting their false vocal cords to actually vibrate. I think that's kind of cool. I'm not a cat person. I still think it's kind of cool. But otherwise, with us, they have no part in sound production. They're just an extra fold out there. Now, when it comes to vocal production, speech is actually defined by and I got to read this one, okay? So don't think I'm coming up with this on my own. It is called the intermittent release of expired air while opening and closing the glottis. So basically, we stop the air as it travels past when we speak. Now, pitch, I know this one. This is determined by the length and the tension of those vocal cords. So if you pull them tight, you obviously are going to have a higher pitch. And if you let them flop, loose, you're going to have a lower pitch, which I think that's pretty cool. Loudness depends on by how much air we're forcing past your vocal cords by using your muscles and your diaphragm, and you can really crank up the sound. And then your pharynx, and remember all this area up here is going to amplify and resonance and enhance the sound quality. But here's the weirdest thing. Because we don't speak when we're children, obviously we're still learning words, but we haven't learned to shape language. We shape language by the action of the pharynx, by the tongue, the soft palate, and the lips. We learn to shape our language. So in case you ever have an interest in speech pathologist or some other area, you'll learn all about this. We don't spend a lot of time on the vocal cords. I just think they're cool to talk about. Here's another thing for that, as far as the vocal cords and the larynx itself, we can actually close off the larynx, right? We do that when we cough. We build up that pressure in our chest. As we hold that larynx, we hold the air in, and then we release it all at once. By holding it in, this is called what's called a Valsalva's maneuver. Valsalva, by the way, was this Italian 17th century physician who came up with it. So in a Valsalva maneuver, your air is temporarily held in your lower respiratory tract by closing up your glottis that we see here. And that causes intra-abdominal pressure to rise when we contract our muscles all around it. We do this to stabilize the trunk when lifting heavy loads. You can see it in the faces of young children when they're not wanting you to know that they're emptying the rectum, they're going to the bathroom. But that's all of the Valsalva's maneuver. So I think that's kind of an interesting use of our larynx. Okay, let's move on down. Let's go to the trachea. The trachea is flexible, and it's a mobile tube that extends from the larynx into the mediastinum, and then it's composed of 3 layers. You can see from my pictures up here. We have the mucosal layer on the inside. We always have a mucosa. Matter of fact, from here on out, just about every organ we talk about, we're going to have a mucosal layer. The cool thing about this, though, is so we've got ciliated epithelium, obviously, because it's going to capture everything. But we also have goblet cells. I don't know if you remember those from the very beginning of the school year. Goblet cells are the ones that create mucus. So, okay, underneath the mucosa layer, we go on out then, and our next layer is going to be my submucosa. In the submucosa, that we're going to find a connective tissue deep to the mucosa, and we start to see some different glands. And then finally, we're going to find the adventia around the outside. So there's my adventia right there. Oh, here's my three. Mucosa is red, submucosa is yellow, adventia is this pink one on the outside. Okay. Now, in the adventia, obviously we've got a dense connective tissue on the outside because that reinforces everything. But here's the important part. Your outer layer here is made up of C-shaped rings. So they're C's. They're not completely closed. They actually have a C. And this is hyaline cartilage. This whole bright blue area is hyaline cartilage. Well, here's why it's C-shaped. This is your esophagus here. This is the one that's food's going to go down. And every time you take a bite of food, it's going to be bigger than this opening, this lumen here of the esophagus. It's going to be a bolus of food, so quite a bit going down. Well, that's going to cause your esophagus then to encroach or move into the space that your trachea is taking up. If this were a full ring, when that food goes by, that would shove that ring out of the way and then it'd come back. That's not good. By seeing the C-shaped, it just moves it into that space and then comes back as that food passes by those C-shaped rings. Now, that's where it works well, and that's the C-shape. But the purpose of those rings, is so that we can keep this area open, this lumen open. Remember what I said before, we've got two tubes here. One of them is sort of muscular and it sort of collapses on itself. You know, I don't have a good example. It's more like a balloon, and a balloon's not going to stay, open all the time. So that's going to be your esophagus that food goes down. The other then is this big open area, okay? So we got this big open area. Well, when it comes to air passing through, the air can't go through that one that's closed down on itself, but you got that big open lumen space of the trachea, and the air is going to just naturally pass down that. And it's those C-shaped rings that are actually holding that open to allow air to enter our trachea. Okay, so now, this was we're still in the conducting zone. So now we can see my picture here. We got our trachea. We're going all the way down. Nothing changes. The carina of the last trachea cartilage, this marks the end of the trachea. And I don't know, it's not marked on that one. It's not marked on that one, not on that one. Sorry, I got to go back. Sorry. I don't have a good picture of that. I thought I would, yeah. There we go. The carina of the trachea. It's that big one right there, okay? Not the best picture, but this marks the end of the trachea and the beginning of the bronchi. So you can see here that this is the left main of the primary bronchus, and there is the right main primary bronchus. So air that reaches the bronchi, it's warm, it's cleansed, and it's super saturated with water vapor. And then, of course, the bronchi then start to divide, each supplying a lobe of the lung. Now, when it comes to air passages, they undergo 23 orders of branching as we reach the lungs. I think that's kind of cool. Okay, so then you can see that we still got those cartilaginous rings all the way down in here. The tissue of the bronchi then mimic that of the trachea. Okay, even as the tubes become smaller and smaller, we continue to have the mucosa, the submucosa, and the cartilage rings. But eventually that's going to change. And as we change, we're actually going to leave our conducting zone, and then we're going to move into the respiratory zone, but we're not quite there yet. So we've been in the bronchi. We still have the cartilage support. We got the epithelium. Something you're going to see is as we change, we're going to get rid of the cartilage and we're going to start adding smooth muscle. So it's a slow process though. It just all of a sudden just doesn't happen. It's slow. And so as we leave the bronchi, then we move into bronchioles. we saw the same thing. If you read the chapter on blood vessels, we went from veins to venules. Actually, we went from venules to veins. It's going the other way. Or we went from arteries into arterioles. So that's going from big into small. So now we're going from the bronchi into bronchioles. Now the bronchioles, we're going to change our cell type. We're going to switch over to cuboidal epithelium. And we're going to complete that layer of circular muscle all the way around that tube. And we're going to lose our cartilage all the way, okay? And so we're just, that's how we change with the conducting zone. So once we do that, we left the conduction zone. So we've hit the bronchioles are done. So now we're ready for the respiratory zone. But I'm gonna put that in a different video so that I don't bore you too much. So let's go ahead and just stop this one here.